Yeah, this is Ndavika Academy. Today we want to look at group theory. We want to look at this key topic here called elementary group properties. Elementary group properties. So that's what you want to look at today. Elementary group properties. They are quite interesting things, and they form keenly the basic of group theory. So if you get to know these proofs well, then you'll not have a challenge in handling group theory. Now we'll start with a theorem, and this theorem here says if you let G be a group with identity, because last time we looked at identity E, if G is in that group, the inverse element is unique. So we are saying if you're having a given group G, and by definition of group, it must have the identity. The identity of a group is saying is E. And if it happens that you have a given element G, then its inverse will be unique. So let's see how we prove this, because you have just said this. So there is facts in this theorem here. One of the facts that this particular group here, it has an identity E. That's one fact. Secondly, from the idea or the concept of group, each element in a group has inverse. So this is another main fact. So we have two things here that will help us to deal with this proof. So that it will mean that we can let a given element X and say Y be inverses to this element G. Because by definition of a group, inverse must exist. The inverse of these elements must exist. Remember, our interest here is to prove uniqueness. So we are saying if we want to prove uniqueness, if truly this X and this Y are inverses to G, then if these inverses are unique, then it will mean that the X and Y mean same thing. So this tells us that we can get Gx. Remember, X here is our inverse, and we do Gy. Remember, Y here is inverse. If you get an element times, or you do an operation to its inverse, by law you get the identity. So that's a fact. We all know that. Now, because we know whichever we are dealing here, we are talking about G. This G is a group. By fact that if G is a group, then it will mean that there exists an inverse such that if you do G inverse, because you know G is the element of the group, then we get the identity. That's again a fact. Now, let's start from where we know. We know this. Let us now introduce this into this. So that if we do G inverse of Gx and we do also G inverse of Gy, we reduce this one to that. So literally, I have not done anything, but we have introduced a very important concept. So that we know in any group, associativity rule or preposition holds. That means we can play with that associativity law here, and we try to do this. We try to do this, group that and that. We try again to group this and this, and then we have this and that. Okay, but that is a fact that we have just introduced here. That if you do G and inverse, you get the identity. That's a fact. So that will mean this will become EX being equal to EY, which is equal to G inverse that. And this tells us that the X and the Y, they are both the inverse. It's the inverse of the of G in this group, which tells us by sure if X, Y is the inverse. That means there does not exist any other inverse, and these inverse are actually unique. So the inverse of element in a given group is unique. And that marks the end of the proof. So make sure, first things first, you subscribe to Ndavika Academy. Okay. Number 2, make sure you share. Share with your friends and the classmates for more of this kind of tutorials. And thirdly, leave any question as a comment. Okay. Until next time, make sure you do the 3.